I want to start this video off with a question. And so the question is, what do all these have in common? You have a golfer who's trying to get his ball out of a sand trap. You have an airplane pilot who is trying to land his airplane. A fashion designer is designing a new dress. And a pool player is trying to figure out the best way to make a particular shot. So what do all of these have in common? They all have angles in common. In some way or another, in all four of those pictures, we're dealing with angles. And all of us at one time or another have to deal with angles. Sometimes we need to measure angles exactly, and we can do that using some very specific instruments. Other times we can just kind of estimate them or judge with our eyeballs what particular angle measures. But oftentimes the proper angle can be the difference between success and failure. And so in this video, we're going to take a look at some definitions related to angles, and specifically as they will relate to our study of trigonometry. But before we can talk about angles, we need to understand what a ray is. And a ray consists of one point on a line and includes all the points extending in one direction from that point. So, for example, if we were to draw a ray, I would have an end point, which usually looks like a dot or a bulleted point, and then I would have a line, and we generally will put an arrow on the end to indicate that it does go forever and ever in that particular direction. That end point is called, that point where we begin is called the end point. And we typically refer to or name a ray using the endpoint. So I might name this endpoint A, and then we need at least one other point on the ray. So this would be ray A, B. And when you name the ray, you always name the endpoint first and then the other point on the line. Okay, so we take two, if you put two rays together with a common endpoint, that's what we call an angle. Okay, another way to define an angle is that we're rotating the ray about its endpoint. So, for example, if I have a ray with endpoint A, and then I have another ray with the same endpoint, but they go in different directions, okay? That common endpoint that the two rays share is called the vertex. And so in our drawing here, the vertex is point A, and then the two rays are called sides, the sides of it. We could call this, it could be named, we could say this is angle A. We name it just using the vertex. Sometimes we'll name it using all three letters, and so there's a variety of ways to do that, but you're always going to have the vertex in the middle. So we could call it, using our angle symbol from geometry, angle CAB, or we could call it angle BAC. In either case, though, notice that the vertex is in the center. Also, within trigonometry, we sometimes like to use special letters, and they'll put that special letter in kind of the angle portion or there at the vertex. So we would write it kind of inside the angle. And some of the more commonly we often use, we could call this angle alpha. Okay, because that's the Greek letter that looks like the fish, so we would read it angle alpha. Some other commonly used Greek letters there are theta, phi, beta, and gamma. So there's a variety of ways to name angles. It's just as easy, if you can, to use either the vertex or the special symbol. Okay, so we often want to measure those angles. The measure of the angle is the amount of rotation from the initial side to the terminal side. Let me back up for just a minute and explain what we mean by initial side and terminal side. Oftentimes, the initial side is the ray where you would start. So in this case, ray AB would be my initial side because that's where I started. Okay, so the initial side is where you start. And then the terminal side is actually where the second ray, and it's where the angle ends. And so when you go to measure, you measure from the initial side to the terminal side. Now, the most commonly used unit for angles, especially when you're dealing with triangles, which is our first perspective that we're considering, is we measure it in degrees. And we know from hopefully previous math courses that a full circular rotation or a full circular revolution contains 360 degrees. So a degree is 1/360th of a circular rotation. And whenever you're indicating the angle measure in degrees, you either have to use the word degrees or you have to use the degree symbol. There is another measurement we use in trigonometry. It's called radians, and we'll talk more about that in a separate video. In trigonometry, a lot we talk about an angle being in standard position. So what does it mean for an angle to be in standard position? First of all, we would superimpose or put the angle on the coordinate plane where you have your horizontal x-axis and your vertical y-axis. And for the angle to be in standard form, the vertex, that common endpoint of the two sides, is going to be at the origin, which hopefully you know is at 0, 0. The initial side, where you will start the rotation, is going to be on the positive x-axis. So basically you have the endpoint on the origin, and you're going to have the initial ray pointing to the right. And then we can rotate either clockwise or counterclockwise to create an angle and find the terminal side of the angle. Okay, so standard position, vertex is on the origin, and the initial side is on the positive x-axis, which means it's pointing to the right. Okay, as I mentioned, you can rotate either clockwise or counterclockwise. And we oftentimes will indicate the direction that we're going to rotate using an arrow. So if I have an angle where my vertex is on the origin, my initial side is on the positive x-axis, and then I'm going to rotate counterclockwise. Again, a lot of times we'll indicate that using an arrow. So I draw the arrow there. And so the measure of this particular angle that I drew here is going to be 90 degrees. Okay, so when you rotate counterclockwise, you have a positive angle. Okay, But we can also rotate counterclockwise. Again, with counterclockwise, you still begin with your vertex on the origin and your initial side on the positive x-axis, but then we can rotate, and we rotate using, again, showing it by the arrow, the directional arrow that shows that we've rotated in a clockwise direction. And when you rotate clockwise, you're going to have a negative angle value. So I've kind of estimated here, but this one is roughly 135 degrees. So we really would say this is a negative 135 degree angle. Now, if you have a negative angle, you need to realize you can also have a positive angle. Because, for example, if we have the positive angle of 90 degrees, had I rotated that the other direction, that would also be the angle negative 270 degrees. On the other hand, had I rotated positively on the negative angle, instead of rotating it negatively or clockwise, if I rotated it counterclockwise, I would have the angle 225 degrees, which is positive. So again, you have to pay attention to the direction, whether you should rotate whether you should rotate counterclockwise or clockwise, and that's determined by whether the angle is positive or negative. We also talk about the angles and where that terminal side lies. We classify the angles based upon the position of the terminal side. If the terminal side lays or lies within one of the regions, the four regions within our coordinate plane, then we say that the angle lies in the quadrant. And I'm going to give you an example of the four types that you could possibly encounter. So, for example, if you had this angle, and I'm just making them up as I go, okay? So I have my vertex on the origin, my initial side, and I'm going to indicate that I rotated it counterclockwise. And notice that the terminal side is in the top right quadrant. And hopefully you remember from your algebra days that the top right quadrant is quadrant 1. Now, it'll be important later on that you're able to identify the quadrant in which the angle lies. And so remember a couple of things about quadrant 1. In quadrant 1, both your x value is positive and your y value is positive. In terms of angles, it's going to run from the positive x-axis to the positive y. And so degree-wise, we could be between 0 and 90 degrees. Okay, for the second one, we could be on, again, vertex on the origin, initial side is on the positive x-axis, and we rotate clockwise again. Again, it doesn't matter whether I rotate clockwise or counterclockwise. Okay, I'm focusing on the region in which the terminal side lies. So again, I can rotate here counterclockwise, and this time I end up in the second quadrant. Top left is quadrant 2. Remember, in that quadrant, you're going to have a negative x value and a positive y value. In terms of angles, you would have between 90 degrees and 180 degrees. Third, vertex on the origin, initial side on the positive x-axis. I'm going to rotate counterclockwise again so that my angle measure is positive, but it could also be negative. It doesn't make a difference. Okay, because what I'm focusing on is the quadrant in which that terminal side lies. And in this third example, I'm in the lower left. And in the lower left, that is quadrant 3. Remember that in quadrant 3, you're going to have a negative x value and a negative y value. Okay, in terms of angle measures, we would be between 180 degrees and 270 degrees. One more. Again, you have the vertex on the origin, positive. X-axis is your initial side. We rotate. And again, the direction of the rotation really doesn't affect which quadrant you're in. If I rotate counterclockwise, I end up in the lower right. The lower right is quadrant 4. Okay, remember in quadrant 4, you have a positive x and a negative y value. Degree-wise, we're going to be between 270 degrees and 360 degrees. Now, we also could have angles where the terminal side is actually on the y-axis or the x-axis. These are called quadrantal angles. And again, you actually have 4 options there as well. You have, if you start out with your vertex on the origin, your initial side is on the positive x-axis so that you haven't rotated any. Okay, so basically there's no rotation. This will be considered 0 degrees. Now, if I rotate a full revolution, okay, then I would have 360 degrees. So the 0 degree angle and the 360 degree angle are actually the same angle. And it's a quadrantal angle because your terminal side as well as your initial side are on the positive x-axis. You could have vertex on the origin, initial side on the positive x-axis, and you rotate 1/4 of the circle, okay, which would be a 90 degree angle, and it lies on the y-axis or on the positive y-axis. Third, you could have vertex on the origin, initial side on the positive x-axis, and we rotate so that my terminal side is on the negative x-axis, and that gives me a measure of 180 degrees. And then lastly, I have vertex on the origin, initial side on the positive x-axis, and I rotate around to the negative y-axis, and that would be my 270 degrees. So my quadrantal angles are 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then I'm back to 360 degrees or 0 since they're the same angle. Okay, so let's look at some examples. If you're asked to draw an angle in standard position, okay, we're not really using the protractor or any kind of measuring tool. We're just going to estimate where we think that would be. So the first one says 30-degree angle. So a 30-degree angle in standard position, vertex on the origin, initial side on the positive x-axis. I'm going to rotate counterclockwise because it's positive. Okay, so we go counterclockwise with our rotation because it's a positive angle. I also know that if it's 30 degrees, it's going to lie in quadrant 1 since it's between 0 and 90 degrees. So I'm going to estimate, okay, I don't have any kind of special measuring tool, but I'm going to estimate where that 30-degree angle would be. So there's a rough sketch, and we're not ready to quite be rocket scientists yet, so a rough sketch is adequate of a 30-degree angle. And again, I may want to indicate the direction that I rotated to ensure that people know that it is a positive angle. Okay, so the second example asks me to do negative 80 degrees. Okay, so again, to be in standard position, vertex on the origin, initial side on the positive x-axis. This time I'm going to rotate clockwise because it's negative. And I also, in this case, because I'm going clockwise, it's going to lie in quadrant 4 since it's between 0 and negative 90 degrees. So it's going to be somewhere along in here. And again, I want to indicate the rotation. So I'm going to show that I went clockwise and that is estimated or roughly negative 80 degrees. All right. Now let's look at a couple more examples. Negative 150. Again, if I want to draw that in standard form, my vertex is on the origin. My initial side is on the positive x-axis. I'm going to rotate clockwise because it's negative, and it's going to lie in quadrant 3. If you'll keep those quadrantal angles in mind, that'll help you to know where to rotate to. So if I start rotating, I go down to 90 degrees. If I go all the way back to the x-axis, it's going to be 180. So it's not quite 180. So again, I'm estimating. I want to show the rotation. Okay, so I'm going to rotate clockwise, and this is approximately negative 150 degrees. The next one may seem a little odd. It asks you to draw the measure for a 415-degree angle. But remember that a full revolution is 360. So it may help me here because really what's happening, you have your initial side, and since this is greater than 360, that tells me that I've gone a full revolution around the circle. Then I got to figure out how much extra I have. So if I subtract 415, maybe come off to the side over here, and I say, okay, 415 minus the full revolution of 360 is going to give me 55 degrees. Okay, so I'm going to end up somewhere like this. But when I show the revolution, okay, and it's important that you show the revolution. Sorry about that. My line disappeared. When you show the revolution, you want to show it that you did actually go a full revolution and then some more. So that would represent 415 degrees. If you didn't show that it was a full revolution, folks would probably think it was only that partial revolution, which would correspond to 55 degrees. Okay, and this one actually does lie in quadrant 1 as well because of the 55-degree angle. Okay, so that's how you draw an angle in standard position. It gives you some background on angles. In the next video, we'll talk about radian measures and look at that relationship as it relates to degrees.